functions and graphs, other types of graphs. Here's an example of a different type of function to the quadratics that we are more used to. Instead of writing it as fx, it's written as f colon x with an arrow. Now we can see that this particular graph or function or shape is repeating itself. There's a particular pattern here, like there would be on wallpapers or screen designs or something like that. You can see it goes down, up, in a regular pattern. We can see that there's sort of a predictability about how this will continue. So we don't have to see much of the graph beyond this point or this point to replicate the whole lot. So here's an example. Identify the period and range shown in the graph below. So for this graph here, you're asked to figure out the period and the range. Now the period relates to how quickly the pattern repeats, how regular it is. So we look at this, and if we go to the bottom here, we can see the bottom point is at -2. And when it comes to the bottom again, it's at 8. And when it comes to the bottom again, it's at 18. So the difference between 8 and 18 is 10, and 8 and -2 is 10. It looks like this has a period of 10 units. We could have taken the high point there, 6, 16, and -4, and that would have told us again it was 10 units. Or indeed we're across the horizontal axis at 0, at 10, and at 20. So there's a number of ways to find the period. So the period by observation is 10 units. The range relates to the highest and lowest y values or vertical values. So if we look down, we see the lowest value here is at -1 and the highest value is at 3. So there's a band of values between -1 and 3 where all the function lies. It just sits in that space, never goes below or above. So -1 to 3 or a total of 4 units as the range. Lowest and highest or the range. So that's what we're asked to do, the period and the range of a pattern like this. We're now asked to find the value of the function at point 4 from the graph, and from that estimate the value of the function at point 84. We look at the graph here and we can see, well, this is grand. We can see the value at 4. We can look up and estimate it, and it looks like the value is 2. That at the point 4, that the value, the height is 2. So we can say reasonably certainly from observation that f4 is about 2. But we were also asked about f84, and that's an awfully long way away, and it would take quite a long time to draw it. But f4 is 2, and also f14 is 2. So it looks like that every 10 steps, just as with the period, f4 would be 2, f14 would be 2, f24 would be 2, etc. So using that logic, in finding f84, we can see that the pattern repeats every 10 or so. Well, precisely 10. So we can take 10 or multiples of 10 from 84. So if we divide 84 by 10, we get 8.4, or 8 truncation, or to the nearest integer. So f of x should be the same as f of x minus 80, or f of 84 should be the same as f4. We can just take any number of 10s from that to get the same answer. So f of 84 should be f of 4, should have the same value of 2. So in this way, we can see that f of 4 is f14, f24, f34, dash, 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 all the way to f84. And if f4 is 2, and f14 is 2, and that's the periodicity, f84 is also 2.